series circuit which is connected to a voltage supply, okay, and there is a multiple of resistors. Okay, this is a positive, negative voltage. Then this is R1, R2, R3. Okay. Then you can use a voltage divider in order to determine the fraction of voltage at each of these resistor. So basically you can calculate voltage at this resistor. Okay. Okay, using a voltage divider. So this is a voltage divider. Okay. So in a series circuit, we know that the voltage total is equal to V1 plus with V2 plus with V3. Okay, so here there's a V2, and then here is V3. Okay. Then in a series circuit as well, okay, in a series circuit, the voltage total is equal to V1 plus V2 plus with V3. And then for current, I total is basically equal to sorry. Alamak, kenapa ni? Sekejap. Okay, I total I total is equal to I1 equal to I2 equal to I3. Okay. Remember that this is as a river, as a flow of a river. So that's why the current flow is equal at each of the resistor. Okay. And then for R total is equal to R1 plus with R2 plus with R3. Okay. Then from this information, okay, we can further develop a derivation in order to calculate a voltage at a particular resistance. For example, I need to calculate the voltage at across the R1. So voltage at 1 equal to I total times with R1. Okay. And then I total, okay, you will refer to the I total from here, which is I1 equal to I2 equal to I3. Okay. And then we know that voltage is equal to IR. Okay. And then I total is basically equal to voltage total divided by R total. Okay. So substitute I total okay, in V1 So V1 is equal to V total over R total times with R1. So basically based on the definition just now, okay, you can calculate, okay, based on definition just now, okay, this is the derivation. The voltage drop across any resistor or combination of resistors in a series circuit is equal to the ratio of that resistance value to the total resistance multiplied by the source voltage. So here, okay, the voltage supply, okay, is the source voltage, okay, and then total resistance, which is this part, okay, and then ratio of the resistance value, so is basically a ratio between the particular resistor with the summation of all the resistors. So this is another way of determination of the voltage. But you must remember the voltage divider only works in a series circuit. Okay. Okay. So this is basically I already explained to you. Okay. Okay. Let's say you need to determine the voltage at resistor 2. So the formula will be R2 over total resistance times with V total. And then similarly for voltage at resistor 3, then it will be resistor 3 divided by the overall resistance, which is the ratio, okay, times with the total voltage. Okay. Okay. So you can make it like this. Okay. Right. Okay, now we try to solve few example. Okay. For this example, okay, determine using voltage divider method, determine the voltage drop across R1, R2, R3 and R4. So now we try to solve for R1. For R1, okay. So based on this formula, it is equal to R1 over R total times with the voltage total. R1 in this case is 1 kilo ohm, okay, 1K divided with 1K plus 1K plus with 2K plus with 6K. Then times with the voltage total, which is represent the voltage supply, which is 15 volt. Okay. Then how much do you get? So basically you get a 1.5 volt. So now you know the voltage across a V1 equal to 1.5 volt. And then for R2, it is equal to, okay, it's similar. So basically you will have a so it's equal to 1.5 volt. Now for R3, so
3 volt.
3 volt.
Yes.
3 volt. Okay. And then for R4,
9 volt.
how much?
9
Again?
volt.
9 volt. Okay, so how you can check your answer whether it is correct or not? Okay, since we know that in a series circuit the voltage total is equal to V1 plus with V2 plus with V3 plus with V4, so it must be equal to the voltage supply. So 3 plus 9 plus 1.5 plus 1.5. Okay, so how much do you get? 3 plus 9 plus 3. So you get a 15 volt. So basically your answer should be correct lah. Okay, now we move on to the okay. Okay, now try to solve this part on your own. Okay, I will ask anyone of you. Determine the voltage across R1 and R2. Muhammad Hazim. Muhammad Hazim,
Yep. Hello.
how much do you get for voltage across V1?
Maybe one. Dah saya tengah kira je.
Dia kira lagi. Okay. Alright.
Ha.
Okay. Okay, I give you another 10 minutes It's okay, no need to rush. Okay.
Saya dapat 10 volt, sir.
10 volt
Ha.
Okay. So basically for R1 equal to R1 over R total times with V total R1 is 20 over R total, which is 20 plus 10 times with 10 volt
Silap sir. 6.67.
times with, so 20 divided with times with 10, 6.66
6.67.
7 volt. Okay, so now for R2 orang lain pula I would like to ask Pay Ye Go. Pay Ye Go, can you hear me?
Yes.
Okay, how much do you get voltage drop across V2?
I got 3.33 volt.
Okay, alright. For R2, this is equal to 3.333 volt. So, it is logic because the summation of voltage across R1 and R23 is equivalent to the voltage supply okay, which is 10 volt but remember, in order for you to apply a voltage divider, you need to series the circuit for this case basically it is in parallel okay, and then what you need to do is to simplify the circuit to be a series circuit. Okay, I hope that you can understand the concept okay, now we move on to exercise 2. Okay, a source supplies 120 volt to the series combination of 10 ohm resistance, 8 ohm resistance and an unknown resistance Rx. The voltage across the 8 ohm resistance is 20 volt. Okay, determine the value of the unknown resistance. Okay, for this part, I want all of you to take this as your assignment. Okay. 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 Simon. Right. Okay. Okay, now we move to the exercise 3. Determine the voltage between the following points in the voltage divider of below circuit. Okay, now okay. 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 So now I want you to solve the voltage between the following point in the voltage divider of below circuit. So you need to calculate the voltage from point A to B, and then from A to C, and then B to C, B to D, and C to D. Then the voltage supply is 25 volt. Okay. Now try to do on your own. If anything you don't understand, you can directly ask me.
Sir,
Yeah.
what is the three layer below at the bottom there?
3 layer.
Yang garis yang tiga bawah tu, yang segitiga
Oh,
bawah.
okay. This is basically grounding. Okay. So basically the circuit is connected to the ground.
Oh, okay.
So is basically grounding can be labeled as a negative polarity. Okay. Okay, did you get almost like my answer?
Yes,
Yes, sir.
Yeah, so basically if you uh sum the value of A to B, okay, then B to C, and then C to D, so basically you will the value will be total equal to 25 volt. Okay. Okay, so now we move to the current divider. In a parallel circuit, the total current into the junction of the parallel branches divides among the branches. Thus, a parallel circuit acts as a current divider. This current divider principle is illustrated in next figure for a two-branch parallel circuit in which part of the total current, okay, IT goes through R1 and part through R2. So this is how a current divider works. When a current flows through a two element which is in each junction, so basically the current will split. So the total current will split into two, which is I1 and I2. So here it is known as a current divider. Okay? But you must remember the current divider is only work in a parallel circuit. Okay. Okay. So if you have this kind of element, okay, which is R1, R2, R3, and Rn. So you must simplify all of these three part to be one simplified component. So there will be only R1 and R2 parallel with R3 parallel with the Rn. Okay. Okay, I hope you can understand. Okay, so now I will show you the how a current divider works based on the derivation. Okay. 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 Now we take a parallel. In a parallel circuit, voltage, okay, V1 is equal to V2 equal to V3 in a parallel circuit. So this is okay. Okay, V1 is equal to V2 equal to V3. And then for current, I total is equal to, this is current flow at I1, I2, and I3. Okay. So the I total here is equal to I1 plus I2 plus with I3. So if you realize here, the current is divided into I1, I2, and I3. So the total of this current will be equivalent to the I total. And then for resistor, okay, for R1, R2, and R3. So 1 over R equivalent equal to 1 over R1 plus V1 over R2 plus V1 over R3. Okay, now let's say we are going to use current divider method to measure the current flowing at V1. Okay. Okay. I will use only 2 circuit just to make it just for example, so no need to go too advanced. I1 and I2. Okay. Okay. Here current flowing at I1 okay equal to V total over R1 okay. So we know that V total is equal to I total R total. Okay, in this case okay, and then substitute so you will get I1 equal to I total R total over R1 okay. So now we have R total over R1 times with I total. Okay. Okay. I need to change here. Okay. Basically here is a current source. Okay. Current source. Okay. Now for R total, okay, R total is basically equal to the R equivalent which is in a parallel circuit, it will be okay 1 over R total 1 over R1 plus V 1 over R2. Okay, now you okay, I think you already know it. So R total will be R1 R2 over R1 plus with R2. Okay. So substitute R total equal to R1 R2 over R1 plus R2 into okay I1. So you will have I1 equal to okay R total R total R1 R2 over R1 plus with R2 okay times with okay actually it is divided so 1 over R1 okay times with I total. I make like this so that you can understand that I will slash okay I will slash R1 and R1 here. If I directly divide then you will sometimes confuse how I cancel out the R1. Okay, so you will have R2 over R1 plus with R2 times with I total. So now we look at the definition. Okay, so this is the formula in order to calculate the current divider at I1. So now the current Ix through any branch equal the total parallel resistance divided by the resistance Rx of that branch, and then multiplied by the total current I total into the junction of parallel branches. Okay, so in this case, the current Ix refer to the I1, which is the current flow to any branch. Okay, the total parallel resistance R total, okay, which is I already calculate here. Okay, basically I simplified, so that's why you only have this value, divided by the resistance of Rx. Okay, so I already explained it is a simplification. Okay, and then it is multiplied to the total current of IT, into the junction of parallel branches. Okay, so I total is the current that before it flow to the junction, okay, which is represent the I from the current source. Okay, now try. Okay, here you can see I1 is equal to R2 over R1 plus R2 times with the I total. Okay, right. Okay, a part of this method you can use a conductance. Okay, an alternative approach is to work with conductances. For n conductances in parallel, it can be shown that I1 is equal to G1 divided by the total of conductance times with I total, and so forth. In other words, current division using conductances use a formula with the same form as the formula for voltage division using resistance. Okay, so basically it is similar with the voltage divider method for conductance. Okay. Now I would like you to try to solve this first example. Ini basically 15 ampere. Then R1 is 10 ohm. Then R2 is 30 and R3 is 60. 30 and then 60 ohm. Okay. Using current divider method, determine current flow at I1, I2 and I3. Okay. So I will give you one example. Okay, for I will calculate for I1. Okay, I1 is equal to, okay, now I write the formula R2 over R1 plus R2 times with I total. Okay. So in this case, in order for me to calculate I1, I need to simplify this circuit. So R2 parallel with R3. So you will get 30 times with 60 divided with 30 plus 60.
Twenty.
Berapa?
20.
Berapa?
20.
20 ohm
20.
Okay, so 20 ohm So now this will be your new circuit Okay. So this is the new simplified so this is the new simplified circuit Okay, so based on this equation, so basically you will get equal to R23 divided with R1 plus with R23 times with I total. Okay. So equal to 20 over R1 10 plus 20 times with the current source 15 ampere. So you will have 20 divided by 30 times with 15. So you will get a 10
And
ampere. Okay, so now you can try to do for R2 and R3. Okay, I will let you guys to do on your own. Okay, I will take some water for me to drink. Okay. Mana? Kelas. Tengah kelas. Okay, so do you already calculate the value of current flowing at R2? Okay, for R2, basically you will have a R13 over R2 plus R13 times with I total. And then for R3, you will have R12, okay, divided with R3 plus R12 times with I total. Okay. So how much do you get for R2? I will, okay, let me call somebody from the Google Meet. Okay, I would like to ask Shasha. Okay, Shasha, how much do you get the current flow at R2?
Still calculate.
Oh,
Sorry.
still calculate. Okay, better.
Sorry.
Better. No problem.
Sir, can I ask something?
Okay, yes.
For the I total, is it same for every calculation? I mean, for calculation for R2, R1, and R3, is it I total too same for every calculation?
Yes, it's same with all the calculation. Okay,
Thank
because
you.
it is the current supply from the current source.
I got R2 for 3 ampere.
3 ampere, okay. Okay, I will put it here. If okay, and then for R3, okay, I will ask another person. Thank you, Najwa.
Welcome, sir.
Okay, I would like to ask another guy, Sanggar Rajan. Sanggar Rajan, are you there? Sanggar Rajan? Sanggar Rajan? Yes, sir, I might problem. Okay, no problem, Sanggar. How much do you get for R3? You can just write it in the chat room. $1.67 ampere. Okay. I'm afraid that maybe the answer is not correct, Okay. How about
Sir, I got 1.67 also.
1.67 also?
Yeah, but for R2, I got 3.33 ampere.
3.3,
Not-
okay.
Yeah,
Okay.
not 3.
Yeah.
3.33.
Okay, so that's mean maybe I also need to calculate as well, Oh, no, okay. I will just check. Okay. Yes, basically for R2, it is equal to 3.33. And for R3, it is 1.67, Okay. I will show, okay. Don't worry, This class is for all of you to make mistake, So do as much as you can mistake in this class, so that you can learn. Okay, so now I total. Okay, in this case, we are going to determine R2. Okay, R2. So the parallel the circuit that we need to simplify is in between R1 and R3. So this is R1 3. So R1 3 is equal to 10 and 60 divided with 10 plus 60. Okay. So 10 times 60 divided with 70,
8.57.
8.5. So may I know who talked to me just now? Sukarna. Okay, thank you, Sukarna. 8.5714 ohm. Okay. So now substitute R13 into this formula. So you will have 8.5714 divided with R2. Okay, I forgot the value of R2. Okay, R2 is 30. 30 plus 8.5714 times with the I's total, which is 15 ampere. Okay, divide with okay, so you will have a value of 3.33 ampere for the current flowing across I2. Okay. Now we move to I3. Okay, I3. Okay. So this is the current source, which is I total. Okay, this is R3. Okay, so the circuit that we need to simplify is in between R2, R1 and R2. So this is R1, 2. Then the R12 is equal to 10 and 30 divided with 10 plus 30,
7.5.
7.5 ohm. Okay. Okay, now we can calculate the current flowing at I3, which is equal to 7.5 ohm. Okay, no need to write the ohm symbol in your calculation. Then R3 is equal to 60. 60 plus 7.5 times with the I total 15 ampere. All right.
1.67.
1.67, very 0.67 ampere. Okay. So overall, you can check whether your answer is correct or not by summing all the I total equal to I1 plus with I2 plus with I3, which is 10 plus with 3.33 plus with 1.67. So you must get a value of almost 15 ampere. Okay. So okay, that's how it works. Okay. And then I will go to, okay, now you can try to solve this exercise. Okay. Okay. Determine the current through each resistor in the circuit of below figure. So determine the current at I1, I2, and I3. Okay. This is the I total. Okay. 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 Ezral Haikal. Ada ke? Ezral Haikal.
Ada sir.
Berapa value current flow at R1?
Boleh nampak lagi sir.
Okay. Calculate dulu Okay, hari ni saya akan upload lab. Okay, so basically dah boleh terus mula untuk buat lab. Okay, for lab platform, kita akan guna simulation. So, I will divide all of you into group. Okay, so make sure your submission is based on the group. So, only one submission for each group. Okay.
Saya boleh tengok soalan tak?
Okay. Alright. Betul. Alright. Dapat 1.32 miliampere, betul ke?
1.63 saya dapat lah.
1.63.
1.63.
Saya
Saya,
pun
saya,
dapat sama.
saya silap kat mana 330 kali dengan satu. Oh, R1. Okay, R20. Okay, R1 640.
Kira kau salah sir.
Macam mana?
Silap tekan kalkulator.
Kalkulator kot salah saya.
Kalkulator salah Jalan kira betul Okay.
Betul.
Alright. So, saya percaya lah dekat student-student saya. Jadi 1.63
3.
3.
milliampere Make sure sebab ni milli So dia milli Okay. So okay, saya salah tekan kalkulator. Betul 680 campur 132. 132 bahagi answer kali 10 milli. 1.63. Okay, betul. Alright. Okay, so for I2 sama dengan R13 divided with R13 campur dengan R2 So times with 10 milliampere. Okay. So I2, okay, saya nak tanya student I2 sekejap. Sekejap. Hello. Salam. Apa saya ada kelas kejap. Lagi saya call balik. Pukul 12.30 tu okey. 12 suku ke? Kalau awal sikit pun okey juga. Nak habis dah ni. 9 minit, 20 minit lagi. Okey, cantik. Alright. Okey, Assalamualaikum. Salam. Okay. I would like to ask Faiz Haikal. Okay, Faiz Haikal. Can I see your face, Faiz Haikal?
Yes, sir.
Boleh saya tengok muka sikit tak? Saya tengok muka anime ni. Pakai baju tak?
Tak pakai.
Boleh, tak apa, saya nak tengok muka student je sebenarnya. Yang saya tengok banyak muka anime ni. Nak kenal juga muka sebenar. Awak study sambil baring ke Faiz Haikal?
Tak ada.
Ada Okey. Okey, Faiz Haikal. Okey, saya pin to screen. Okey, Faiz. Macam mana kita determine value pada I2?
Mula cari R1, R3 dulu.
R1, R3 tu dia kena parallel ke? Kena series ke?
Parallel.
Parallel. Okey, parallel. Okey, kemudian R13 mesti divided with
ni tambah dia.
tambah dia. Tambah apa?
R1 R3 lah. Dia punya
R13 dan
R R R2
R2. Okay, alright. Okay, and then kalikan dengan
kali dengan 10 dia
10
punya
milliampere current source Okay, dapat berapa jawapan dia for I2?
3.35 ampere.
3.35 milliampere
Milliampere.
Alright, sebab kita kalikan dengan milli. Alright. Okay. Okay, Faiz. Boleh tutup.
Terima kasih.
Sama. Okay, jadi okay, for R3 for current flow at R3 saya nak sekejap dua orang. Okay, Tan Jun Zun. Okay, can you please switch on your webcam?
Yes, sir.
Okay.
No, sir. Sir, can you hear me?
Okay, yes. Okay, can you switch on your webcam?
I already switched on.
Oh, but okay. Alright, okay, yes, I can see you now. Okay, so Tan Jun Zung. So how much do you get for current flowing at I3?
5.02 milliampere.
5.02 milliampere
Yes.
So basically you dividing what with what? Can you please explain to me?
The value, is it the value or
No, just the resistor.
or R1 R2
Okay,
R1
R1, R2, okay.
and R12 plus R3.
Okay, alright. That's all I want to know. So as
Okay.
long as the method is correct, then the answer should be correct as well. Okay, Tanjung Zung. Okay. I hope you can understand all
Yes,
the
sir.
teaching.
Yes.
Okay. Okay, that's all. Thank you.
Okay, thank you.
Alright. Okay. So you will basically get a value of how much is it just now?
5.02.
5.02 milliampere. Okay, so now I total equal to 1.63 plus 3.35 plus with 5.02. Okay, equal to 0.63 plus 3.35 plus 10 ampere. Okay, 10 milliampere. Okay, so basically 10 milliampere is equal to the current source. Okay, so basically your answer should be correct. Okay. Okay, I will give you another assignment and then you can submit it in the column. Okay. Okay, this is your last assignment. Okay. Okay. You can okay, you can write it and submit through the column. Okay. I believe that's all class for today. Thank you for your time. Okay. For your lab, I will upload the lab report, the lab sheet into the column, and can you submit the report by Friday. Is it possible? Okay. Okay. It's okay. You can submit to me the report by next week, Monday, because it is the first report. Okay, no problem. Okay, and I will upload the lab sheet as well as the platform for you to simulate the circuit. Okay. So you are going to use that simulation in order to determine the current, the voltage. Okay. Okay. And you just follow the instruction inside the lab sheet. Okay. That's all class for today.